How many people do we have? Okay, we have 9 people. I think that's enough to get started. So today, can you guys all see my screen?
Yep.
Okay. So today I wanted to maybe start with this example, and we can keep messing with this example and see where it takes us. And so this is a module called Class 2. Here's our schema types. So our database is just a public schema. Our schema has a users and emails tables. The users and emails tables look like this. Okay. And on the Haskell side, we have a user type, and we're giving it generic instances, and also show. So to set up our schemas, we go from the empty public schema to our database type. And we have to create table users and create table emails. And we've already discussed that last time, so there's no need to belabor that. And to tear down, you drop table emails and then drop table users. But this is a new thing that we didn't talk about last time, a migration. So this is an example of a migration, and this is what is called a rewindable or reversible migration. Because it has this ISO, that means that it has an up and a down. So it's invertible, right? And so inside of this migration, we put the setup that we defined here, this definition, and the teardown, which is this definition here. And that's where this definition is coming from. So when we say ISO Q of definition, that means give me a definition in this direction, that's the up, and a definition that goes in the opposite direction, that's the teardown. Okay? And migrations, you can parameterize them. I could have done a one-way, so I could have just made it one way, like that. That would have been fine. But I wanted it to be reversible, and I wanted it to be pure SQL. I also could have done IO in here if you want to, if you want your migrations to include running applications or doing arbitrary IO, that's doable. But this one is just pure SQL definitions. Okay. And here's our insert user statement. It's not too different from the last class we discussed. So it's a statement. It's type checked against our database type. You give it a user, and there's no return value because you're just doing an action. You're inserting the user, right? And we use a with statement to insert first into the users table and then getting back the identity that it generates. We use that to insert into the emails table. Okay. So here's also the query we had last time, select all users, which just gives back all the users that are in the database. And here's select users by name, and I want to implement that next, but we'll discuss that in a little bit. Here's a session. This takes place in the PQDB monad, okay? So when these two variables match, then this PQDB is a monad transformer, right? When these don't match, when they're different databases, that just means that it's an index transformer. So we can't just treat it like a normal monad like we do here. Since it's just a monad transformer over a monad, that means this whole thing is a monad. So we can use do notation. So what are we doing? We're asking user, how many users do you have? And then we're going to figure out how many users. And then here we're defining our loop where for each user, we're asking what is the user's name, what is their address, and then we're inserting them using execute params underscore. The params means that this takes a prime argument, and the underscore is because it's not returning anything, so we don't need to void it or anything. We can just put that underscore there. Then we'll run the loop however many times, and then we'll get all the users back, and that gives us a result. And from the result, we'll ask to get all the rows from the result, and then we'll just go ahead and print that. Okay. And then main, what it's doing, so now we're going to run our migration that we defined earlier, and migrate up takes a path of migrations, right? So each...
Hey, Tom?
Yep.
Are you on the VPN by any chance? A couple people are having trouble getting like your feed very smoothly.
I am on the VPN. Should I not be?
I mean, maybe not. I mean, maybe it would make it a little snappier.
Maybe not. Okay, I'll try not. Sorry, guys. I don't have the best internet. I generally have problems when I'm like hosting video and displaying my screen. So if my screen freezes, let me know. Let me turn this off. Okay. And did I miss a question? I heard a ding. Okay.
Just talk about the capture, yeah.
Okay. Okay. So we were talking about running these migrations, right? So migrate up takes as its argument a path of migrations, right? Because you could have your migration that goes from your version 1 to version 2, version 2 to version 3, right? So you can run a whole path of migrations. Here we're just running one, so it's just migration 1, and then I'm done. Migration 1, and then I'm done. And here I'm going to migrate it up, and then I'm going to run my session, and then I'm going to migrate it down. And this is I could have just done just as easily. I could have just done this, right? Define setup and define teardown, which is essentially what this is doing, except that if I do it with migrate up and migrate down, it's a little safer because it'll run that migration in a transaction and it'll check that those tables are there already. Whereas if I define setup, let's say session throws an exception, so I never reach this teardown, then if I do it with a migration, it won't complain that those tables are still there, even though I haven't migrated them down. Okay, so this is just to show you how to use migrations as well. Okay.
Can you expand a bit on the part about checking that the tables are already there? Is it related to the things we are doing in our migration system in which we check which migrations have already executed and we just skip those?
Yeah. Yes, of course. So that's the basics of any migration system, is you somehow store some state that says which migrations you've run already, and if you've run it already, don't bother running it a second time, right? Just run the new ones.
And is the way in which you're determining whether a migration has already been ran or not by checking whether the tables that you expect to see from the type level exist or not?
No, this is actually doing it just the way like I actually sort of looked at how the Rails active record was doing it. What it does is it stores so if we look in the database, you can see that there's this schema migrations table. So it creates this schema migrations table.
So there are more tables that are not accounted for at the type level.
And it says, oh, look, we've run migration 1, and here's when it was run. Okay. So let's run this main. Main is saying, first we'll migrate up, and then, and this is running in the index monad, so that's why we're using this notation. So we're then running our session, and then we'll migrate down at the end if it's successful. So let's run this. So how many users? Say 2. We'll say username A from a.com. Or, oh, I can't erase. That's interesting. B.com. And okay, so here came out the users at the end. Okay. And it gave us a notice that schema migrations already exists, so it didn't need to. So it did a create if not exists schema migrations when it was doing the migrate up, and gave us a notice. So we can also here see what happens if I try to. So I have a constraint on the users table, right? That the username has to be unique. So what happens if we try to enter 2 users with the same name? Okay, so we get a SQL exception, duplicate key values, unique constraint. Okay, so how are we going to handle this? So we can actually, this is a SQL exception. We can actually catch it and say, oh, try again, right? So let's do that. We'll say handle squeal. So this is happening when we run this insert statement. So let's handle it, and we'll ask GHC, okay, what do I need to do to handle it? I need to, given a squeal exception, do something with it, right? So let's define our handler, which when it runs into a unique violation and some message, we'll say, let's tell them what happened. Got a uniqueness violation. Try again. Okay. And then we'll run the loop, right? And otherwise, we'll just rethrow the error, right? So let's see if this works. Haven't tried this yet. Oh, we need to turn on Lambda case. It should really be on by default. No instance for isString. Oh, I can't lift IO a string. I have to lift IO put Sterling. Okay, so now let's try running main again. And we'll say we have 2 users. Oh, got a uniqueness violation. I guess we inserted it in on the last time. So maybe we should actually run this transactionally. We can run the whole thing transactionally. In fact, we'll say we'll just run this transactionally.
What is the argument to the unique violation constructor? Like, what
A
is that?
message. We can go ahead and see what that message looks like. Okay, let's refresh. Doesn't like that because this is a byte string, so we should unpack it, but I don't actually care, so I'll just show it. Okay, let's say 2 users, and A's already in there, so it'll complain. Oh, no, it's not. Okay. Error, duplicate key violates unique constraint uke name. Okay. So now we have the message. All right. And we're running it transactionally, so we're not getting the same problem that we're getting before. Oh. Uh-oh. Transaction is aborted. Okay, what happened? Some kind of transaction error. Okay, I don't feel like looking into that too much. Let's go back to this. Select user by name, right? So how would we? So now, since the username is unique, we could select user by name, and try that instead. How would we define this? Well, we could just straight up define this, right? And just add a where clause, right? And where user dot name equals param@1. Okay, it didn't like this. Why not? Oh, it doesn't like this because it doesn't realize that this is a one tuple. So there's a couple things I can do. The easiest thing would be to make it a new type. A new type is a one tuple. Only is like identity or whatever. It's the one tuple. Uh-oh. Okay. I don't want to do it that way anyway. So I will do this explicitly. So we're have a single parameter and generic row. Okay. So this tells it that I just have a single parameter, not a tuple, not a more than one. Okay. So this is select user by name. Let's do it in here. Let's ask. We'll execute params, select user by name.
I have a question about the pros and cons of using execute params versus having like things inlined into the statement.
Yeah, let's talk about that too.
Sure.
So one way of doing parameters is out of line, and another way of doing parameters is inline. So here we've run this thing, it compiles. And this is an example of an out of line parameter. And the way you execute it is you run it with execute params, either with or without an underscore, and you give it a parameter. But that's not the only way you can give things a parameter. You could also make it inlined. So we could do this. Okay.
That seems a lot more natural to me. Under which circumstances would we want to use the other approach?
Oftentimes I like to use the other approach when when I have like an insert that I'm running on a big container of users, let's say, and then I can use a prepared statement to run it over the list, right?
I guess I'm not familiar with SQL enough. I guess a prepared statement is faster than the regular statement?
Well, prepared statement is faster when if you're going to run it multiple times. Every time you run a SQL statement, it does first preparing it, and then it runs it, right? So if you're going to run it multiple times, by preparing it, you're saying just prepare it once. So that's an optimization.
Makes sense. Thank you.
But that's not the only way you can do it. You can still do it with inline. If you have multiple of these, you can. There's ways to inline all of them, right? So you could still make it into a single statement. It's just an option. It might be more natural this way, if you prefer.
Is the performance like you send the query one time versus n times, basically? Like is it substantially better, or?
I would be hard pressed to know. Like, certainly if you're inlining it, right? You're inlining the values multiple times. Those are all different statements, right? Because they have different values inlined into them.
Sure.
And so you can't. So that's definitely, if you're running each one of those separately on each input piece of data, that's definitely going to be slower than using an out of line parameter and preparing the statement. But if instead you inline all of the values into your statement, then that's only one statement. And so that might be comparable in speed or even maybe potentially faster than preparing the statement and running it on a bunch of out-of-line parameters.
I guess I'm just confused what preparing it is. Like you send it to the SQL server and you say, hey, give me a reference to this so I can then apply this as a function? Or I just don't know what that means.
Yeah. So prepare creates a prepared statement. Prepared statement is a server-side object that can be used to optimize performance. When the prepare statement is executed, the specified statement is parsed, analyzed, and rewritten. So when you run a SQL statement, Postgres does a lot of work to like optimize it. And you don't necessarily want to do that every time you run that statement. You might want to just do all that optimization once and then execute it on a bunch of different data, right?
It seems to say the execution plan depends on the specific parameter values.
Okay. Yeah.
So it's to avoid inlining, basically. It's to avoid us doing the work of inlining, but it's not clear if we're faster at inlining and
Parsing and
or
analyzing
yeah.
and rewriting.
Yeah.
It's doing this stuff only once.
okay. So the analyzation, like the analysis rather, is like a prerequisite to building the execution plan. Okay, that makes sense. I'm satisfied.
Okay. So this is another way to do it, and since now we're doing it that way, we should say that this is in parentheses. And let's see. Oh, now we don't need that because there's no parameters. No instance OID PG unit arising from query. What's it complaining about? Line 88. Oh. Now we can just use query. Or we could have used nil params. Or generic params. Which is just the same thing as query. Okay. So that's the difference between inline and out-of-line parameters. But this is still kind of dissatisfying because you can see there's a lot of repetition here, right? So ideally, we might want to reuse this query inside of this query and just say from select all users, select the ones whose name match this, right? So let's do that. So to do that, first of all, you don't really compose statements, you compose queries. So we're going to have to break this thing out. And in order to do that, let's figure out what its type is. Okay, so let's say that select all users, instead of being a statement, has this type here, which we'll analyze in a second. And we'll get rid of the query bit. Okay. So this is compiling. Let's clean it up a little. Just cleaning it up.
So for the first one, it expanded out the type synonym, but for the second one, it kept the colon.
Yeah, I don't know why it does that.
Strangely inconsistent.
colon is just a shorthand for pairing. pairing at the type level pairing. Okay, so this is our select all users, and we can go ahead and say, okay, we're just going to select star from subquery select all users, and we have to give this subquery a name. We'll call it sub.
Is subquery an SQL keyword or a Squeal function?
A Squeal function.
Okay.
Okay, and we'll give it a where clause. And now we need to check that the username, because remember this thing is giving us a username, equals n. Okay. So now you see we are composing, right? So we're using this query inside of this query. And if we were to print out,
This makes me very happy.
Me too.
uh-oh. We see it just inlines select star from select. So here's the thing that we're inlining as sub. Okay.
I think your screen is frozen for me. I don't know if it's the same.
Yeah,
for-
I was just about to ask about that. I was gonna say.
Here, I will try stop presenting and presenting once again. Okay, let me know when my screen
Looks
freezes.
good
much
for
better
right
now.
now. Yeah.
Yep, I see a blinking mouse.
Okay. So here's our select user by name where we're calling select all users. So statements and queries. Statements is just you take your query and you wrap it in a way that tells Squeal how you're encoding and decoding its parameters and decoding the rows, right? So it ties it sort of to the Haskell side, to the Haskell types. But the queries, which are pure Postgres or pure SQLs, you can think of it, and they're typed with pure SQL. We can go ahead and make this. Oh, no, doesn't like that. Okay. So this is pure SQL, but because this is a generic query, I could use this type family here. So this could get rid of this and use this type family and make this a user. Okay, so now I'm using query underscore. So even though I didn't change the body of select all users, it looks like I changed the type. I actually did change the type, but you can see I changed the type. Okay, so now this looks a lot more similar to the statement, right? But it's kind of a trick because query underscore is a type family. So if I ask what is the type of select all users, it's actually still the same old type without the underscore. Okay.
Well, I guess it's a little bit less polymorphic, right? Like,
yes, it's a little less polymorphic than it was before as well.
And I was actually going to ask a question about that. Like, when you're piping,
piping hot.
when you're piping inputs, like not of the inline sort, but of the other sort down through the queries that you're reusing, do all of them have to have the same params list, or can they differ? Or
They certainly all have to have the same params list, but if you're polymorphic, that's one way to have the same params list, right? Like, so
Sure.
when I had this, right, which is very generic, you can see that the params was polymorphic. So this will work no matter what this params list is. On the other hand, if I said, you know, and where e dot name equals param at 1, then I had better have at least, you know, a parameter here, and that parameter had better be not null pg text.
And that leads to my second question, which is like, do you have classes which will like constrain what's in your params so that you can be polymorphic but still like
But still use a parameter?
yeah, exactly.
You would just do like I just did, right? There's no need for a type class for that. You would just
Well, with what you just did, since you're using @1, you're hard coding that you're using the very first parameter. So if you had two different queries that both wanted to use a parameter, they would need to coordinate, I'll use number 1 and I'll use number 2 or something.
They would certainly have to, and that's a requirement of SQL, so that's nothing I can do about that.
Okay.
So I have a question. So the way you've like composed these this is essentially like the SQL way of like, you know, we know that you could have done this in SQL, right? Because like if we look at the SQL generated, it's sort of composed with the SQL statement itself, right? So if I were like, what I've done in like Event Historian is sort of compose this in I would sort of a more Haskell-y way, and I don't know, I just sort of compare and contrast. So like, I had, you know, like select all users as the statement, and then I parameterized, like I took in essentially I had and where f, and I took in the f as an argument, and so I don't know, I just sort of
Yeah, there's all sorts
get
of ways
your
to do
thoughts
that,
on
and
that.
yeah, because there's so many ways to drill down into the statement. So okay, at the very top level, we were a statement, right? Underneath the statement, we were a query, and then underneath the query, there's all sorts of little pieces, like what is the type of this guy, right?
Right.
Maybe I can factor him out. Oh, he's some kind of weird expression. The point is, it's an expression. Okay, and maybe I can factor that out and make that a parameter to my term, right? On the other hand, what I saw you did a lot is you took these table expressions and said these are really the things that I want to factor out, right? Because I might be selecting different things always from the same table expression, and this thing I'm seeing over and over. So let's factor that out, right? So let's try that.
Right.
So what is the type of table users as U and inner join tables emails as E on u.id equals e.userid? What is that type? So it's a from clause, blah 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 blah. So let's actually do that. We'll say
Actually, I'm curious, if you don't mind,
join
what are the bloody blahs here? Like, what do each of these params represent?
Yes. So this first one represents any lateral context that this is in. So if you do like lateral joins, right, there might be some extra context for tables that this thing can reference, right? So that's where this first variable is giving you. And here I'm saying, no, I'm at the top level. I'm not in, I don't have any lateral context. Okay. With is a context for common table expressions. So if I'm in a with statement, then I have common table expressions which I can reference, right?
Sure.
DB is my schema, my schemas, right? And here we have our params, and we have I'll just leave that underscored because I don't even want to deal with this. But what is this? This is the so-called from type, which means I have a bunch of tables, a bunch of what are called table expressions. Not really, but I basically have a bunch of tables joined together, right? Vertically
Right.
or horizontally glued together. And so that's what's going on in this variable here, which I'm just going to leave blank for now. And I'll say join
Right.
table
So it's saying we have a U. Oh, sorry.
equals, equals this garbage. Okay. And let's get rid of that. And we'll say let's go ahead and say from join table. Okay, what isn't it like? Did I miss some? Okay. Yeah. Okay, I guess I did need that. Okay, so what is this join table? It consists of U and E. Oops.
Yeah, I will say one disadvantage of this approach is a lot more long type signatures to write out.
Yeah. I think probably the query level is actually what you want, and just use a subquery rather than really breaking this thing out. But because the query planner will optimize it anyway.
Right.
But you can do this, is the point, if you really want to. Okay, so we can say that this is what this is. If I take table to row of, or you know what, even let's take columns to row of user columns. And this will be columns to row of email columns. Users and emails columns. Couldn't match type from clause.
You have the from in both places.
Oh yeah. Okay. So that's another way we can factor that out. Maybe it's worth sort of exploring. So we talked about that there's the very high level of statements, slightly lower level of queries and manipulations. We've also seen definitions, which are for create, drop, and alter, which are run a little bit different. They get run in the index monad. But let's drill down into the smallest atoms. So the smallest atom is an expression. And there's lots of ways we can create expressions, right? And there's expressions everywhere. So if we look in here, this parameter is an expression, right? We can look where that comes from. It comes from parameter. So I have this param, and param gives me an expression. I also have parameter, which I give it an explicit type, and it'll give me an expression. So if I say what I want to print, SQL parameter 1 int. Nope. Set type applications. Damn you. Okay, didn't like that. So we can say, so it didn't like that because it couldn't infer this thing. But in a statement, you don't run into that problem because you've already said what the parameters are. You fix that, so it's able to infer. That's parameters.
I'm curious when you would use that rather than param.
What? Oh, when you so param is when it can infer the type from your database, right? There's not necessarily a good reason to do param because now it can infer pretty much any type that you have. But sometimes you have types that are anonymous, right? That don't have a name, like some anonymous composite type, for instance. That's the only case where I think you would have to use parameter. It used to be that you had to use it for like composites and stuff in general, but now Squeal is better at inferring those things.
Thank you.
So inline is the opposite, right? So we talked about parameter is out of line parameter. Inline is for obviously inline parameters. So these ones are pretty simple. We can print SQL inline a character. We can inline. What happens if we inline 5? Oh, it doesn't know what its type is. Oh, it defaults to double. Okay. So we can inline 5 as a double. Could inline it as a float. We can inline it as a int32. Let's import data.int. Okay. And in fact, you don't even need to inline a number because we have this probably won't work. No. Because we have a num instance for expressions. Okay, doesn't like that, but we will. Oh, from integer. So let's do it this way. 5 is an expression of type not null, e.g. int32. Okay. Oops, int8, yes. Okay. So you can see that we can just use the num instance directly. So there's nothing stopping me from doing right. I can. Oh, so this is the is string. So there's an is string, and it's just the same thing as inlining. So this would be the same thing. Oops. Except that it doesn't know that this is string because we have overloaded stuff on. Okay. So that's inlining. We have all sorts of JSON you can do. Operators. Oh, type expressions. So you saw me calling parameter with a type expression. So I might want to cast an expression to another. So I can do true and cast int4, right? Or I can say, what if I said as type int4? It would say, oh, it can't match it. But if I said as type bool, then it just includes an annotation of its type. And I can even say as inferred type, and it'll add a little type tag to it. So that's pretty nice. Type expressions. This lets us use a type def. So if we've defined types, and that's probably something we should do next if there's time, there is. Let's add some types to our schema. Okay. So I want my user to have a favorite food. Okay. And it's actually going to be their favorite type of shawarma. Okay. And we'll say that data shawarma is either lamb, beef, or chicken. Okay. And we'll go ahead and add shawarma field to users. And what are we going to put here? I'm going to put PG of shawarma, whatever that happens to be. Okay. And I'm going to also go ahead and add to my schema, before I've even defined users, I'm going to define shawarma, where shawarma is a type def of PG shawarma, whatever that is. So shawarma, remember, is a Haskell type. So here I'm directly embedding my Haskell type into Postgres and into my schema. Okay, so it's going to complain, no instance for show shawarma. I don't know why that needs to be there, but let's go ahead and derive it. Okay, what's it complaining about? 58. So it says it couldn't match empty with emails. It's not really helpful, but we know what's happening. We need to add another, we need to create enum, create type enum, okay? And we're gonna create it directly from the shawarma type, and we're gonna call it shawarma, okay? So I'm directly embedding my Haskell type into the database. Okay, what's it complaining about now? Okay, so we also need to add a, now we have a, now we can use this type def, right? So now we have type def shawarma and not nullable as shawarma. Okay. Okay, so now it's complaining about the teardown. So after we've dropped users, let's go ahead and drop type shawarma. Okay, 79. Okay, so when we're inserting a user, we also need to go ahead and set param3 as shawarma. Okay. And let's maybe line this up a little. Okay, what's it complaining about now? Oh, it's complaining about that. Okay. Well, this is not a very useful message. Oh, here's 124. Okay, so so it's not matching. We also want to go ahead and do e dot shawarma as, and what did we call his favorite shawarma, right? Let's line these up too. Are you guys still hearing me?
Yep.
Okay. What is it complaining about here? Ba-ba-ba-bum. Oh, because this should be user.shawarma. Nope. Couldn't match empty with favorite shawarma arising from as. That looks right to me.
Could it be the order? Sometimes order is an issue.
I think I did it in the same order, right? So user has favorite shawarma last, and shawarma is in the user's column. So it should just work. I'm probably missing something. 96. Okay, let's just say that we have one last one here. It really doesn't like this. Oh, I know. So we can say, in fact, why don't we just go ahead and say row PG user. And we'll say that this is now, once again, u dot shawarma as favorite shawarma. Okay, so now it couldn't match PG shawarma with blah 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 blah, right? So it doesn't know what PG shawarma in fact is. We haven't told Squeal how to associate shawarma with a database type. So to do that, we're going to derive GHC generic, and we're going to also derive SOP generic and SOP dot has data type info. And then finally, we're going to derive via enumerated, because we want an enum, shawarma. And I guess we don't need those parens, do we? Oh, the via goes at the end, doesn't it? I forget always. Okay, so what do we want to derive? We want to derive is PG. That tells me that what its PG is. We also want to derive to PG on our database and from PG. And we might as well make it inlineable too. And we need to turn on undecidable instances, which sounds scary, but it's actually fine. Oh, it doesn't like this because P we'll just make that. This is a little bit of an annoyance with GHC that it can't apply a type family inside of certain contexts. So we can make this polymorphic. Doesn't matter. Okay, 128 doesn't like. Where's that? So we will insert it with our favorite shawarma being chicken. Every user will like chicken best. Okay. Okay, so this is how you add your own Haskell type into the database. And you can do that with not just enum types, you can make also composite types. So if you have a record, you can do that. Any questions? I guess I got frozen again.
You're all right for me, but
No questions? What do you guys want to talk about next time? What would be helpful?
Probably decoding.
What?
Probably decoding would be helpful. Just
Decoding? Explicit decoding?
I think so. Yeah. I mean,
Okay.
what do you guys think? Does that sound helpful?
I second that.
I'd love to talk about decoding. I'd also love to like go through some of the like basic types at the sort of bottom, like the types that you can avoid seeing by using the nice syntax, because I sometimes run into them and I feel like I'm limited by like not having written the library, and like almost like a ground up view of it rather than like a user's perspective. And I know that's not the scope of this necessarily, but maybe if we could do another meeting for that. I mean, I'm just really interested in that.
Sure. Yeah. Maybe you and I can talk about that.
Sure, that sounds great.
Okay. That will be it for today.
Thanks a lot, Eitan.
thanks so much.
Welcome.
It's great.
Thanks. Bye.
Thank you
Bye.
so much.
See you next week.
Thanks, Jason.